Almost 30 years ago, the high-speed line from Hanover to Würzburg was taken into operation by the German Federal Railway. On the 11th of June 2019, work started on the complete rehabilitation of the section from Hanover to Göttingen. The investment for the renewal of the section of line on which trains are running at 250 kilometers an hour is huge. DB is talking about 140 kilometers of track, 47 turnouts, 243,000 sleepers and 404,000 tons of ballast. How does this work? How does Deutsche Bahn go about it? If we take visitors to the tracks these days, what is happening there? We always try to show our visitors the impressive machines from Plaza and Teurer. For example, the ballast recycling machine and the track renewal machine. These are machines that you don't see that often in Germany, even though they are usually deployed for track renewals. But it's quite something to renew 147 kilometers of track in terms of size and quality.
Das ist schon ziemliches Ding.
As far as I know, there have not been any projects of this size at DB. This means that a great deal of planning work was required over several years in the run-up in order to achieve a successful result of this. Shall I say, exertion? It's important to point out the large amount of ballast, the large amount of sleepers required. This made it necessary to start the sleeper production last year and then store them. It took up the capacity of several sleeper production plants in Germany to produce the sleepers just for this section.
Die Kapazität von mehreren Schwellenwerken in Deutschland gebunden hat.
You see the ballast recycling machine is shown here in the top section. With the chain where the ballast is excavated and then sorted with the use of braking facility and the screens. And the old material moves forward into the large bulk material wagons. Any new material required is fetched from the rear, delivered and then reinserted here, behind the chain, so that we will have again 100% ballast. What is the quality of this clean ballast, and what is brought back into the track by the machine?
Der Schotter, der ins Gleis eingebracht wird,
the ballast that is brought back into the track is literally of the same quality as new ballast. At this work site, the requirement was that the actual new ballast is washed to keep the generation of dust as low as possible during installation.
Hier ist so ein Stein auch, der recycelt ist.
Here we have such a ballast stone that is recycled. It shows that it has been lying on the track and that the edges are just slightly rounded. But on the whole, the interlocking capability of the ballast is still good and does certainly not justify a replacement with new ballast, which would not only cost a lot of money, but would also not make any ecological sense. Here, for example, we have new ballast that was delivered directly from the machine and that will make up the remaining 20% after 80% of the ballast has been recovered through recycling. Why is there such a high share of recycled ballast compared to new ballast? Normally, you would expect a service life of about 60 years for ballast. The ballast here is 30 years old, so it's not surprising that a large amount of old ballast can be reused. Also, we must bear in mind that some parts of the Hanover-Göttingen section were rehabilitated a few years ago, which meant that a fair amount of new ballast was already installed back then. Therefore, it's not unusual that we can work with a large share of recycled ballast here when renewing the track. The bottom section shows the fast track renewal machine. Both machines are from Plaza and Teurer. Here, the old sleeper is picked up, moved to the back, and the new sleeper is also brought in from the back on these transport cranes that are running on rails at the top of the vehicles. The new rails are delivered here. After the ballast has been adjusted, if you take out the old sleeper, you end up with a bump which needs to be leveled off. In addition, we also make a small depression so that the sleeper lies well when it is positioned and does not start moving and end up being broken from too much stress. The machine with all its technology ensures that this does not happen. At the front of the Renewal train, the rails are unfastened from the sleepers. All sleepers along this section of track will be fitted with so-called sleeper pads during the track renewal. This means that a rubber mat is concreted in under the sleeper. This will ensure that the dynamic loads acting from the sleeper onto the ballast are kept to a minimum, so the track can be operational for longer. The padded sleeper type first caught on at the Austrian railways and is only starting to be used by Deutsche Bahn. This letter on the wall here looks interesting. Mr. Borner, what is it? This is a reminder of the opening of the line on the 2nd of June 1991. It was stamped on the 2nd of May, but this is because these letters used to be pre-stamped. The line was put into operation on the 2nd of June 1991. There was a big gathering at Kassel Wilhelmshöhe station, and I remember standing out there with my father, and when we looked up to the dike in Giften, we saw the first trains go past like white flashes. My father was really impressed. So was I, of course, and above all, it was a really nice experience for me, since I had been part of the whole thing, if only to a very small extent, which then started to operate so successfully. Special moments always used to be when breaking through a tunnel, when the two tunnel halves actually came together. You stood at the front and then you could suddenly see through the tunnel. This was certainly very impressive. Another event I remember well is the last sleeper that was installed between Göttingen and Kassel to set up the connection between the northern branch and the southern branch. From then on, we know the infrastructure has been completed. Now the line will be equipped with all the facilities, and in 1 or 2 years, trains can finally run on it.
Jetzt ist es ja eine zweigleisige Strecke, eine Hauptstrecke, die komplett gesperrt worden ist.
This here is a double track line, a main line that has been fully closed. Why did you decide for a complete closure? You could have left one side open and run the train traffic on that. What were the reasons for a complete closure and the resulting diversion?
Umleitung auf den Weg zu bringen.
Einer der ganz entscheidenden Gründe.
One of the key reasons why it was finally decided to have a complete closure are the tunnels. The tunnels that we have on this section of line. And further ahead of the high-speed line between Göttingen and Würzburg, there are even more tunnels. We have to provide ventilation systems in the tunnels on a large scale. This would restrict the availability of the tunnels considerably. For the safety of the workers on the track, trains wouldn't have been able to run at 250 kilometers an hour on the adjacent track, but probably only at 90 kilometers an hour maximum.
Wahrscheinlich maximal 90 Stundenkilometer.
That would have meant such a big change to the actual timetable that it was decided to go back to the old track. This will then also allow us to work more speedily. So, this diagram shows the whole section of construction from Hanover, Lützen to Göttingen. The sections that need to be renewed are shown in red. The sections in brown are those that will be renewed in the conventional manner. For example, around turnouts where we said they will be lifted with the track panel, and then the ballast will be excavated completely and the new ballast inserted. Finally, a new track panel or turnout panel will be put back.
Thema Gleislack.
Regarding the track geometry, what type of work will be carried out there?
Der Stopfexpress
The Tamping Express ensures that the track geometry, as it's been established by the Renewal train, is the actual nominal track geometry. This basically means the track will be slightly lifted and the right and left rails are brought to the same level in the straight.
ein bisschen angehoben und die linke und die rechte Schiene werden so auf das Niveau gebracht.
In curves, where there is a cant, the outer rail is brought to a high level by tamping under it, so that the required cant is achieved in curves.
Damit sie höher wird, damit wir dann eben die notwendige Überhöhung in den Bögen haben.
In the traditional curves, we'll tamp to the nominal value from a zero cant, and this is done by the tamping machine.
Das macht dann eben die Stopfmaschine.
Welche Arbeiten schließen
What other work will be carried out when this is completed?
Wenn der Oberbau
Once work on the permanent way is completed, we'll also work on the catenary within this construction project.
Fahrleitung
The catenary will have to be readjusted. The distance between the top of the rail and the catenary must be reset. Also, parts of the catenary will be renewed.
das dann
Once this is all done, there will be work on the command and control technology. In this case, this means putting up signals in some selected positions and laying the so-called line cables throughout, so that the trains can communicate with the signal boxes continuously in order to be able to travel at the permitted maximum speed of 250 kilometers per hour.
50 km/h fahren können.